Most of us learn how to count when we're really little. One, two, three. But that's really only half the story when it comes to numbers. Today, we're going to dive into the complete story, a world that includes values below zero, from the deepest parts of the ocean to something as simple as owing money. We are talking about integers. So let's just jump right in with a massive question. Really think about this for a second. What's the total vertical distance from the tippy top of Mount Everest all the way down to the bottom of the Mariana Trench? How would you even start to figure that out? And trust me, it's a bit trickier than you might think. Well, to answer a question like that one, our good old counting numbers just aren't going to cut it. They're great for things we can, physically count. But what about concepts like elevation that's below sea level, or a temperature that drops below freezing, or even when you overdraw your bank account? And that's really the heart of it, right? Our world is just full of opposites. We've got profit and loss, up and down, hot and cold. To actually describe this reality, we need a number system that can handle not just gains, but losses too, a way to talk about values that are, in a sense, less than zero. And that brings us to the hero of our story today. Integers. They are the beautiful, elegant solution that lets us map out this entire world of opposites. And the key to understanding them is a really simple but incredibly powerful tool. So what exactly are they? Well, integers are basically the complete set of whole numbers. Think about all the counting numbers you already know, 1, 2, 3, and on and on. Now, just imagine each of them has a sort of mirror image on the other side, -1, -2, -3, and right there in the middle, holding it all together, you've got 0. And this is the perfect way to picture it. The number line is our visual map. Zero's our home base, our origin point. Think of it like sea level. Everything to the right is positive, moving up. Everything to the left is negative, moving down. It's this perfect symmetrical system. All right, so we know what they are, but how do we actually use them? It's kind of like learning a new game, right? Once you get the rules down for adding, subtracting, multiplying, and dividing, you can pretty much solve any puzzle they throw at you. Adding is actually surprisingly straightforward. If the signs are the same, say you're adding -3 and -4, you just add them up and keep the sign, so you get -7. If the signs are different, like -3 and +7, you find the difference, which is 4, and you just take the sign of the bigger number. In this case, that's a +4. Easy! Now, subtraction has this fantastic trick, a real game changer. The golden rule is this: don't even bother subtracting, just add the opposite. So 5 minus 8 is really just 5 plus -8. And what about 5 minus -8? Well, that just becomes 5 plus +8. It's a simple little flip that makes everything so much easier. Okay, but here's a heads up, a really common tripwire. With addition, the order doesn't matter one bit. -5 plus 8 is the exact same as 8 plus -5. But with subtraction, the order is everything. 5 minus -8 gets you +13. But if you flip it, -8 minus 5 gives you -13. Two totally different answers. Okay, multiplication. This is where things get really cool. Forget trying to memorize a bunch of boring rules for a second. Let's just think about this in terms of friends and enemies. A plus sign is a friend, a minus sign is an enemy. The logic here just flows perfectly. A friend of your friend? Well, that's your friend too. So a positive times a positive is a positive. The enemy of your friend, that's definitely your enemy. So a positive times a negative is a negative. And my favorite one, the enemy of my enemy is my friend. So a negative times a negative becomes a positive. It just makes sense. And you're gonna love this. You don't have to learn a whole new set of rules for division. Why? Because they're exactly the same. If the signs of the two numbers are the same, the answer is positive. If the signs are different, the answer is negative. That's it. Done. So we have the definition, we have the rules of the game. Now we can finally go back to that monster of a puzzle we started with. We are officially equipped to solve it. So let's reframe our problem using our new language. The top of Mount Everest is at an elevation of positive 8,848 meters. The bottom of the Mariana Trench is way down at negative 10,911 meters. We want to find the total distance separating those 2 points. So, to find the difference between a high point and a low point, we subtract. That gives us the equation 8,848 minus negative 10,911. And what's our golden rule for subtraction? We just add the opposite. So the problem instantly becomes 8,848 plus 10,911. And there it is. The total vertical distance from the highest peak on Earth to its lowest depth is an incredible 19,759 meters. Understanding integers just made solving a world-sized problem totally straightforward. Pretty amazing, right? All right, let's tackle another real-world puzzle. Imagine a test where you get 5 points for a right answer, but you lose 5 points for a wrong one. There are 25 questions in total. How on earth could you end up with a score of exactly 110? Well, there are actually a couple of ways to pull this off. The direct route is just getting 22 questions correct. 22 times 5 is 110. Simple. But you could also get 23 questions right, which puts you at 115 points, and then get one wrong, which adds a -5 to your score. 115 plus -5 also gets you to 110. So as you can see, integers are this really powerful and consistent system. They give us a clear language and a solid set of rules to describe the world around us. But even in this nearly perfect system, there is one single, very mysterious exception. And this isn't just about math problems on a test. This is the language of the stock market, of outer space, of your bank account. Integers turn these abstract ideas like up and down or profit and loss into real, concrete numbers we can actually work with, which makes it all the more bizarre that there's one operation that just breaks. And yet, for all this beautiful logic, there's one thing you just can't do. You can add, subtract, and multiply by any integer you want. You can divide by any integer except for one. The expression a divided by 0 is officially not defined in mathematics. So my question for you is, why? Why does this one operation break our entire elegant system of rules? Now that's a question to chew on.